Now, we have a symmetric set of data. A symmetric set of data is called a normal distribution. It has 100% of the data underneath its bell. It's symmetric bell-shaped, and the mean, median, and mode are all at the center. So right here in the middle are the mean, median, and mode. We don't care much about the mode in this particular class. We're going to focus more on these. And for now, we're really focusing on mean because on a symmetric data, we talked about earlier, symmetric mean is the center. Median is for skewed, and this is not skewed. Now, so this little symbol right here is your mean. This little symbol right here is your standard deviation. You have to get used to the Greek symbols for those two words. It's very important. The mean is always in the middle. Your standard deviation is your steps over. So when I take one step to the right, that's one standard deviation added to the mean. Take another step, that's 2 standard deviations added. Take another step, that's 3 standard deviations. Standard deviations, again, are the steps to the right and steps to the left for the data. Now, another thing is if your mean's in the middle, if you take one step to the right and one step to the left using a standard deviation measuring stick, that means that 68% of your data should be in between these, or 34 on the right and 34 on the left. Also, if you take 2 steps to the right and 2 steps to the left, you get 95% of the data. You can get 99.7% of the data within 3 steps in both directions. So basically, on the edges, it's very, very unlikely, but it is possible to get numbers outside of that. So these steps and percentages are going to be very important to understand and reference. So a teacher has 150 students, and their test scores had a normal distribution with an average test score of 79 and a standard deviation of 7%. So we have a normal distribution, and our mean is 79. So I'm going to stick 79 right in the middle, because that's our center. 79 is our center. And our standard deviation, or steps, are 7. So I'm going to add 7 to the right, and that would be 86. If I add 7 again to that, that would be 93. If I add 7 yet again, that would be 100. Again, mean goes in the middle, plus 1 standard deviation, plus 2 standard deviations, and so forth. Now we're going to go backwards and subtract a standard deviation and get the other side. So if you subtract 7, you get 72. If you subtract 7, you get 65. If you subtract 7, you get 58. So what this means is that between 58 and 100 is 99.7% of these students' grades. So very few people, very few people failed, because failed would be about right there, 60%. So people did fairly decent. So let's answer these 4 questions from our normal distribution picture. The test scores are 2 standard deviations from the mean. So what scores are 2 standard deviations from the mean? So I'm talking about this one, which is 93, and this one, which is 65. So that would be 65% and 93% are my 2 test scores that are 2 standard deviations from the mean. What percent of the students got between 72 and 100? So 72's right here, and 100's right here. So I go 72, so that means I have 34, 34, 13.5, and 2.35. Add all that up, and that would be from 72 to 100. Now, to do that, I'm going to add the 34 plus 34 and just do that in my head and know it's 68%, because 64, see this right here? That's 68. Sorry, 34, 34 is 68. I can do that grouped. Then I'm going to add this, and that'll get us to 100% on the score. So 68 plus 13.5 plus 2.35. When you add up all that, that tells you that 83.85% of the data, of the scores, are between 72 and 100%, which is almost about, like probably 84% might be a C or better. Pretty good scores. Next, about how many students got grades from 1 to 2 standard deviations below the mean. So the key here is below the mean, and it's 1 to 2 standard deviations. So below the mean, here's the mean, 1 standard deviations here, 2, so we're talking between that, so we're talking 13.5%. So that's what we're looking at right there. So 13.5%, but the question's asking how many. So if we go back, weren't there 150 students taking the test? So if there's 150 students, I want to take 13% of that. Well, 13% is 0.135 as a decimal. And if you take 150 times 0.135 and multiply that, you'll get approximately 20 students. All right, there is our answer for that one, which should make sense. 13% of that, 20%, 20 students does sound right. Last problem. We want above 72%, number of students. So 72% is right here. Above that means all of this, all the way to the end. So if I want to add up all those percents, well, from the mean over, since the mean and the median are equal, and since the median is a middle, won't this be 50% all of that? So won't that be 50% plus 34? So that would be 34% plus 50% would equal 84% of the students got from here over. Now, how do you find 84% of 150? Just like this. I'm going to take 150 students times 84%, which is 0.84, which would be 126 students, which hopefully makes sense because 84% of that, 126 sounds about right. So for all these type of questions, first thing is you want to label your bell-shaped curve. Next, you want to make sure you understand these numbers and how it breaks down. And then just read the questions. If they ask for percents, give your percents. If they ask for number of things, you got to take your percent and multiply it by how many were in the survey or the data.